Now covering a non-spam email is basically equivalent to covering spam emails, right? So the feature design is not just about being representative of class, but even within a class there may be subclasses. So there could be spam emails which are say invite versus spam emails which are buy something. So you need to cover multiple subclasses, or we call them modes within a class. So what's possible is, let's say I am trying to, this is spam, this is non-spam is everything other than outside spam, right? So this is just spam, but spam itself might have blobs inside. This is buy something, this is invest in something, this is visit us. So feature design can be tricky. Any other issue that you see? I mean, we have listed a whole bunch of problems, yeah.
We need to convert the answer into some mathematical.
Okay, so that's another challenge. So first challenge was feature design, so that you are representative of all classes. The second is the model. It has to do partly with the model, partly with the error function. So I would say 0 and 1. So how do we treat y? So y is no longer a real, it's some C1 to Ck. So in regression I could say, linear regression closed form was W star equals phi transpose phi inverse phi transpose y, but here y was real and I don't have this luxury straight away. What is one hack? Let's say I want to, I just learned so much on linear regression that I want to apply it for classification. What would you do?
For each of these
So you'll say 1, 2, 3, 4, 5. So Sunny is 1, Rainy is 2, and blah blah blah, right? So a poor man's solution to classification using regression would be Sunny equals 1, or let me just say C1 equals 1, C2 equals 2, C3 equals 3. The actual values, right? I am trying to predict. Whenever class 1 occurs, is 1, class 2, 2, class 3, 3. Does it sound appealing? Do you see some serious issue? What's a serious issue?
You can't like impose an ordering.
Okay, so how could you impose an ordering? That's so I am repeating his point. So let's say this is class C1, this is class C2, this is class C3, and let's consider a two-dimensional feature space. This is just say phi 1, this is phi 2, right? Since we already mentioned basis functions, I am just developing on that. So there are two basis functions, phi 1, phi 2. Now C1, C2, C3, saying that C1 maps to 1, C2 maps to 2, and C3 maps to 3. Visually there is no ordering as such here, right? I mean very often this is a partial order. You have studied partial ordering, right? So there is no way I can compare several pairs. So it's possible that dry versus rainy could have some ordering in some sense, but dry versus rainy versus sunny doesn't make sense all the time, right? Or spam versus non-spam, so in two class case, even then I can kind of, okay, let go, two class 1, class 2, or 0, minus 1, 1, we'll see that today. So often you do minus 1, 1, but for multi-class it doesn't make sense. Okay, so it's a poor solution. and it's poor is because unnecessarily imposes ordering. Okay, a slightly less poor man solution is what? Instead of y being a scalar, I could make y into a vector, and that is often done. So better idea could be that y1 is represented as 1 in the first position and 0 in the other two positions, y2 0 1 0, y3 0 0 1. Now these are not necessarily, there is no ordering here. However, then you need to develop more machinery. You can't say I have already learned regression, I am going to force it. No, you need to study, you need to develop more models, develop methods by which you can do this kind of regression on vector valued outputs, right. So this is exactly where now we are going to spend some time on. We need to develop on models, develop on the machinery that we are demanding. And our first attempt at doing this is Perceptron. So we will see what it means to deal with discrete outputs. So Perceptron is our first attempt at handling discrete, because these 0 1 0 1 1 0 1 1 1 0, these are all 1 0 0 whatever, these are all discrete valued outputs, they are no longer continuous, right. Okay, can I move on? So the problem setting clear, and I hope I have sufficiently motivated why regression is going to fall short. We need more machinery, and what I was trying to illustrate there on the left hand side is why regression is inadequate to handle classification. Can't impose ordering on y's when it is not there, when it is not required, or when it is undesirable. It is not just about not required, it is undesirable. So now we will move on to the perceptron algorithm. Now I just want to also, before we move on, I also want to say that in general what we will do is we may not necessarily come up with only a single function x going to C1. The reason we also build on perceptron is we want a cascade of such functions. So x goes to some y, but what is that y? Y is some intermediate space, right? So it is possible that within the C1 I have some intermediate representation by f, and within the f I have another intermediate representation g, or another mapping to another intermediate representation g. Okay. So this is f circle, and within that I could have another g, and within that another h, and so on, right. So basically as I said, spam may not be of one type, There could be multiple types of spam. We saw this case here. So instead of modeling all of them together, we'll say I'll have F, and within that I have a G, and within that I have an H. So basically create substructures, right? So it's not creating but inferring hidden substructures. Okay, so 5 varieties within C1 and 3 varieties within C2. This is what the job that F might do. But within each of those sub varieties, you could have sub varieties. Yes, so there was a question.
So why don't we solve the problem using this and solve it on the order?
With using what? Regression.
1, 2, 3.
Yeah, you will get some solution, but it may not be meaningful. The accuracy may be poor. Yeah, see, this is where you bring in bias, right? What are you doing? When you bring in class mapping, this is bias. So we want to reduce that bias, because increased bias will lead to underfitting. You have seen that. This imposes high bias, which we want to reduce. Right, so having this series of hidden substructures also has the effect of reducing bias. Because you are increasing the search space. You are saying, oh, everything is not one kind of spam. Spam has varieties, and that spam sub variety could also have sub variety, giving more flexibility to the classifier. Yes, so kind of there's a funneling out and then funneling in, because the C1 to CK may be just too narrow for you to directly jump into. So we will see more of this, yeah. Intermediate class representation, you are creating more variety, right? So the degrees you get, right? You get a computer science degree, a mechanical degree, right? You get some fixed number of degrees, but within each stream, as you go through the 4-year process, you might take a BTP project, a bunch of electives, which are like your subclusters, right? So suppose I want to classify a student as CS degree or mechanical degree or some other, right? Now, just saying that I am going to have one layer will basically mean that, oh, all CS students seem to be taking the same set of courses, which is not completely correct, because you have electives going forward. I mean, the kind of projects you may do in your courses might be different. So what you are saying is that intermediate, let's allow that CS itself is a bunch of substreams, right? And yes, thereafter, that is F. F will say substreams within CS, substreams within mechanical, and so on. G will say, well, all that is fine, but I want to still put together my final classifier. The query was not whether this guy is doing AI or networking in CS, but the query was whether he's a CS guy. Right? So that's the job that G and H will do. They'll again funnel down. So that's a very good question. So this is the problem. So now once you start saying, oh, there's an F and a G, who will regulate what that F and G means? What will the question was, what if this G and F and G start misbehaving, misfiring, right? They may take you away from computer science altogether to bio or some other field, right? So that's a very good question, and that's where we are assuming we have, let's say we have a lot of data. If I have a lot of data, then that data will probably prevent me from drifting away. But these are issues that will keep coming up. Very good questions. So please note, there isn't so much space for me to note everything, but let's try and moment you look at nonlinear models, I could just do it here itself. Good question. So let's proceed. Any other? So we'll see that. So if you have more data, it sometimes it becomes, yes, it's a trade-off. It's all a trade-off. There's no black and white rule here that will always help. It can also misfire, as I said. We are reducing bias overall. We are saying that if I wanted to find the degree that the student has, I can try and first fit the sub degree or the sub discipline within this person, in which this person kind of has developed expertise, and thereafter through that route. So now I am allowing multiple routes. I am just giving you multiple paths to CS degree, right? So it's basically you're increasing model complexity. Increasing model complexity can reduce bias. Where did I say F is a subset of C1? Here. It's not a subset. I'm just saying that F takes you, I didn't say F itself. F takes you to some space within C1. So it's possible that these classes are overlapping. Yeah, you guys are thinking ahead of me, but that's good. So it's possible that these C classes may not be overlapping. That's the other thing. So mechanical and CS, thanks to minor etc., would have overlap. Yes, on the subclass level. So F might also be taking you here, right? So good, very good questions. But overall, this decreases bias, can decrease bias. I won't say it will always decrease, but this by increasing model complexity. Okay. Is there any other nagging foundational question? Please do bring it up. So F is basically taking you to a space which is more fine grained, right? So F is more fine grained, G becomes less fine grained, H can become very coarse grained, mechanical versus CS. So the substructure is because it's taking it all depends. If how you define F will determine whether it's fine grained or coarse grained, but you can make F more fine grained. Yeah, but exact. So objective is to go from very fine grained examples to coarse grained classes. But should you do it in one hop or multiple hops? From every student, should I directly go to CS versus mechanical, or should I say, well, these guys, bunch of CS guys, bunch of guys seem to be doing ML, these guys seem to be doing networking, and then from there progressively make it coarse grained or make it coarse grained in one shot. That's the choice. Yes, exactly. That's the intent. So that's why labs are there. You'll see that it's not always easy, right? Even sometimes binary classification, spam versus non-spam. I've given you enough examples. Spam, what is a spam? Just sit and write down some rules for spam classification. All of you get spams? How many of you are lucky to never get spam emails? So no hands up, right? Everyone gets spam. Everyone is lucky or unlucky. So then try and write some rules. ये कीवर्ड आया तो spam है. देखो कितनी जल्दी थक जाते हो, right? So you'll probably realize why we are talking about all this. So Okay, so we will move on. So the perceptron classifier is a linear classifier. Object is to learn a linear classifier, and it basically functions as follows. Here are some. So I am going to use now output as +1 and -1. With two classes +1, -1 or 0, 1 is not an issue, because I mean the issue becomes when you have multiple values to compare, just two values, one less than other, one greater than other really does not mean much, right. So for two classes we are okay. I won't say make any difference, make much difference, because it's just two classes. The ordering actually starts mattering when you have multiple classes, right. So let us say we use red for negative and blue for positive. And our goal is to come up with this classifier, this linear classifier. Now because it's linear, we will continue using W transpose phi x. But what exactly is W transpose phi x meaning here? If, so B, as I said, will play hide and seek. So currently let us hide B. I want you to articulate what should be the behavior of W transpose phi x. Right. So the question was, what if you just at least in this two class case, why not just do regression? You can, but let's try articulating what is the one desired behavior we want. Okay, whether you do regression or classification, what is the behavior we want of W transpose phi x? That is the question to you. So let us assume that phi has a component which includes the bias term. In fact, let me start with a simpler way, where we let me put this plus b, let us put this plus b. Okay, so my question is, what is the behavior of fx for y equals -1? What should be the behavior of fx for y is +1? Answers please. And what exactly is w doing here? What is w? Is w the line itself? Is w a perpendicular to the line? Yes, is it the line or a perpendicular to the line? So the way you visualize is that w is indeed a perpendicular to the line, and this is a w vector, it's a vector, and the sign that y is +1 or -1 should correspond to the sign of W transpose phi x plus b. If a point lies on one side, then the W transpose phi x plus fx basically should be negative, on the other side it should be positive, right. So this fx for the positive points, what do you expect this to be? Greater than or equal to 0. Here fx will be less than or equal to 0. Now we can break ties arbitrarily and say, well, anything lying on the point is a positive, belongs to a positive class. We don't want to live with ambiguity in the definition. So does this make sense? Now I want to learn a classifier, right. So somebody said, basically treat it as a regression problem. I am going to now go one step slow. I mean, you can try regression, but let us say I want to approach it in terms of what how should behave for a new point, right? Because regression will give you a W, but you have to make sense of that W, and you have to use fx for classifying a new point. That's the proof of the pudding. It's in the eating when you get a new point, right? So what should happen? What will be your decision on that new point? So let's say this new point, new input pattern, any new input pattern similar to a seen pattern is classified correctly. So x, so if x is here in this negative set, you would like fx to be less than 0, right? And that's how you will determine the class, whether you solve it using regression or any other method, is how you are going to use it. So you will say I will to learn this classifier such that for my point x, if x happens to be here, then if x is less than 0, if x happens to be here, greater than or equal to 0. This is for a new query input pattern. Okay, so now what we are going to do is, we will say, let's think very simple, childlike, right? So if this is what I expect from a new query pattern, what does it mean to have a similar expectation from input patterns, the training data? I am going to insist that training data also behaves similarly, right? So children get irritated if parents have different standards for themselves and different standards for children, right? So why you ask me not to eat, but why are you eating pizza? So obviously I will also eat if you eat. So that's exactly what the logic we are going to use. We want to treat the training input patterns like we would treat the test input patterns. So then my question is, how can we now develop our training algorithm? So the question is wk plus 1. I want to learn a wk plus 1 equals wk plus something, some component that moves classifier toward this desired behavior. Okay, and what is the desired behavior we are talking about? This desired behavior. This is clear? So let's try and develop the algorithm now on the board. I will initially have W0. What to initialize that to is a question. So initial weight vector, and until some criterion is met, wk plus 1 equals wk plus something, where the something should honor that w transpose phi x. Now this b can be absorbed, but let's keep it this way, is less than 0 if y is minus 1 and if y is plus 1, this quantity is greater than or equal to 0. This is the expectation. Is there a way that I can get rid of this if? Any obvious way I can get rid of this if? I don't want two statements there, or in the board also, right? I don't want these two statements. Yes? Signal function, but something else, much simpler. What if you multiply the first equation by y and the second one by y? What's a necessary condition? The product should be greater than or equal to 0. Strictly greater than 0 is a sufficient condition, greater than or equal to 0 is a necessary condition. I mean, that equal to 0 is a problem for us in the sense, so largely we will try and avoid, or try and avoid experimentally that cases where points lie on the line. But anyways, for the time being, So the compact necessary condition is y times W transpose phi x plus B is greater than or equal to 0. Right, clear? And this is going to drive this is a necessary condition, but if I put a sufficient condition, I'll say greater than 0. Greater than 0, then certainly I'm fine with both cases. So we'll see whether we want to do necessary or sufficient. I'll let the greater than equal to right now. So as I said, B is often indirectly captured by including it in W and using phi as just the augmented phi. So hereafter we'll just use W transpose phi x. So I'm going to drop the B and include the component B in W by augmenting phi with a 1. So I'm going to further simplify this. Okay, so W transpose phi x equals 0 becomes a separating hyperplane. Okay, so now let's get to the algorithm. Going over all the existing examples. So let's say I have these positive and negatively labeled examples. I'm going to going over all of them. If a point is already correctly classified. So let's say my W0 was here. This is my W0. Everything above should be positive, everything below is negative. And let's say my query point is this one. Is this correctly classified? Likewise, all these guys are also correctly classified so far. This is also correctly classified. So what will I do if I come across a point which is correctly classified? Should I update the classifier? Should WK be updated? No, there is no need. And this is how we learn, right? So as kids, they try some experiment, press a button or two in the mobile phone, the song doesn't come on, then they try click some other button. That's how you do. So if something worked, then you repeat it. Something didn't work, you try something else. So if it worked already, why change your strategy? So if correct, then leave WK plus 1 as WK unaltered. Do nothing. Continue. But if not, which is if I come across a point which is incorrectly classified, so let's say this is not the point, so let's say this is the incorrectly classified point I come across. Okay, and likewise, well, there's no incorrectly classified, but let's say I had this point here, this point here, right? That's incorrectly classified. So what will I do if I come across an incorrectly classified point? I have to keep in mind that this is the desired state. So what update on W will get me to the desired state? I want marginal correction, which is only that, and this is, as I said, we will now think like children do. Children don't think, अरे आगे जाके job कहाँ मिलेगा, JEE crack होगा कि नहीं. I mean, they don't think. It's parents who put all this nonsense into children's minds, right? So children think, okay, will I have fun playing or not, and then where will I get the best immediate returns? So you are not going to bother about all the other points sitting there. Whether I am going to be classified correctly or not. So how will I get to this state? I want to do this for this query point, any one of them, say positive or negative. I want a strategy that works for both, positive as well as negative points. Increase phi, increase W by how much? Okay, so first of all you have to realize this we are updating. So this is desired, right? This is the desired state. But you are updating it when? If W transpose phi x is less than 0. That's when you are updating. Right? What characterizes those 2 points? These misclassified, incorrectly classified point, what will happen here? The negative point, W transpose phi x is, let us say, greater than 0 for this negative point. For this positive point, W transpose phi x is less than 0. That is why we say it is misclassified, right? So in summary, sorry, I meant y times W transpose phi x if it is less than 0, right? In both cases, y times W transpose phi x is less than 0. Then I know that it is misclassified and therefore I have to update. Okay. So what is my update here? Okay, so I am going to just suggest divide by Wk minus Wk, yeah, you can think of multiple strategies. A simple strategy that really works in the sense in practice as well as very easy to show that it tends to better classify the immediately unclassified point, is to just simply add eta times phi x. Some eta is a step size, all of you are familiar with step sizes by now, but phi x, just add phi x when the point is misclassified. Okay. That is a simple strategy we are talking about. So all this, if for x when I say W transpose, now I mean Wk transpose phi x into y is less than 0. Eta, sorry, good point, very good point. It is not just eta, it is eta y.
Same question for gradient descent, and for this fact, why do we not incorporate a factor which kind of shows how far off we are from what it should be? Because
good question. Right. So the question is, why are we not incorporating a factor which says how far, how badly classified the point is? We will see that perceptron does this to some extent, but it is not as explicit. Let us proceed. We will see that perceptron handles this to some extent. Right. So what is this W transpose phi x? So it boils down to that question. Now let's get to the core of the point. By adding to the weights of quantity as proportional product of input pattern with the desired output, and that is what we showed. Okay, so this is the update, and now we are going to try and understand this eta. I have used x prime, y prime instead of x to make it explicit that we are dealing with some query point. Query point in the sense from the training data set. Okay, start with some weight vector, and for k equals 0, 1 to n, for every example denoted by x prime, y prime, do this only when x prime is misclassified. Okay. Now let us try and get into what this quantity is. Very important discussion. So as we have already hinted, W is a normal. Okay, now imagine 2 points. Let us refer to this point. W0. Okay, let me. What's this with that W0? Okay, this was my W0. And I had this corresponded to W0. But what is W0? W0 is basically this normal and when it actually pointing in the direction of the positive class. So this is W0, right? Now we'll try and understand what W transpose phi x means. So let's say there are 2 points, one on the separating surface. So this separating surface is W transpose or phi transpose W, right? This is a separating surface, which means that if you have a point here, a point on the separating surface, the value of W transpose phi is equal to 0. I will remove this superscript 0 because it just gets cluttered. This is W, this is some W, right? So here, let's say this is a point x tilde, y tilde, I don't, yeah, x tilde, that's it. So at this point, W transpose phi x tilde equals 0. Is that correct? At this point. And this is my x prime. This x prime is misclassified. Everyone sees that is misclassified with respect to this W. So at this we have W transpose phi x prime. What is that? It should be negative. It's misclassified. That's what we are saying. But what does it mean? What is the distance between this point and this point? Let's now measure the distance. What is this distance? This distance is measured along the perpendicular. So it will be yes. So we are dealing with which space is this? The space of, we are dealing with the space of phi. This is, let's just say phi 1, this is phi 2. Should I draw this figure again? Make it more explicit? Okay, let me draw this again so that okay, I'm going to remove all the unnecessary stuff. So here's my classifier W transpose phi, and I know that for x bar it is 0 because x tilde it is 0, where x tilde is here. This was a positive point, misclassified, and I call this x prime, and my query was what is W transpose phi x prime? What does this mean? Right? We are saying it should be less than 0, but what does it really mean? So now what is my interpretation of W? It is this perpendicular pointing towards the positive class. This is a positive class, this is a negative class. Okay, and now I am going to, if this is the point x bar, this is the point x prime, my question is what is the distance between x bar and x prime such that phi x prime minus phi x bar is perpendicular is along W, which means the line joining the vector that connects x bar to x prime is perpendicular to the separating surface. That's the distance I am talking about, the distance along the perpendicular. So what will be this distance? It will be, pardon? Yeah, but how do you compute this distance? It is dot product, right? So if I want to find, let's say the 2 points, distance between 2 points along a particular direction, along what do? I project, right? Equals projection of phi x prime minus phi x bar on W. That's a projection. And what does the projection evaluate to? Dot product. So it's W transpose phi x prime minus phi x bar what is W transpose phi x bar? For any point that lies on the separating surface, I have already written W transpose phi x bar is 0. So what does this evaluate to? W transpose phi x bar is 0. It will just be W transpose phi x prime. Is this clear? So W transpose phi x prime is the distance of a point from the separating hyperplane measured along the perpendicular to that hyperplane. So it's a perpendicular distance, right? It's a perpendicular distance of a point from the hyperplane. Is this clear? This is a perpendicular distance we are talking about. I mean now this is not necessarily scaled distance, that is okay, I mean it's just a dot product. It's relative. So since we are comparing one point against another point in the same space, we don't have to necessarily kind of scale it properly. This is the distance we are going to use. So you might want to kind of bring everything to some, let's say between one phi and another phi. I might want to kind of divide by the norm of phi. So somebody may say, what if the phi's are very, some phi's are very unnecessarily bloated up, right? For example, if my phi is in kilograms against grams, so you may say phi in kilograms and phi in grams, the distance should be the same. Everything is, all weights are in kilograms, all weights are in grams, features are in grams. Distance should be the same, but that will not be the case with this because the magnitude of phi will matter. But that's okay because we are dealing with the same phi right now. We are not trying to compare against two different scaled versions of phi's. That's all I meant. But let's say this is the distance. I mean this is the distance actually, just that we have not normalized it. So now, is this assigned? Is it always guaranteed to be less than 0 or greater than 0? No, that's the whole point. That this distance is a signed distance. It's perpendicular distance, but it's a signed distance. So I'm going to further qualify it. the sign distance. Okay. So which means that it will be positive or negative. Okay. On the other hand, when you do a y times w transpose phi x prime, this is unsigned distance. Unsigned distance means you are multiplying by y, so that if it's on negative side, multiplication by y will make it positive, so it's supposed to be the actual magnitude, right? And when do we say that a point is misclassified? When the unsigned distance starts getting a sign. Distance is supposed to be positive, uska sign kaise aa gaya? So now just very simple common sense. Something is supposed to be unsigned, how does it become signed? That means something is wrong, right? So very simply said, all we are saying is, if unsigned distance becomes signed. Imagine your friend taking you to a treat and say, this is my treat to you guys, and after eating the food he says, all of you pay your bills. So how do you call it a treat, right? So this is what if it's supposed to be unsigned, it should be true to the word. So what we are trying to do is basically correct this unsigned distance and make it actually unsigned. And this is exactly what the update rule will try and do. Okay, we will see. So we quickly see how this update rule tries to make, I won't say it makes, but tries to make unsigned distance actually unsigned. Okay. So let's just see this action. So here's the classifier, this is the current state. So think of this as W0, and we pick this point, this was my initial x prime, and this x prime is used to trigger off a movement in the classifier to make the unsigned distance of that, which is supposedly negative, make it more positive. Does it make it positive? Well, it just manages to. This is what happens when you get W1 as W0 plus y prime phi x prime, and you can put an eta if you want here. So this is W1. This is not W1, but the classifier corresponding to W1. See, W1 is always going to be perpendicular, but hereafter when we say this is W1, we mean the classifier with the W1 normal. I hope we don't have to keep saying that every time. Now it found another x double prime. It says that this has a negative unsigned distance, right? And unsigned becomes signed in the sense it became negative. For when we say signed, we mean it's negative. So it has become negative, x double prime's unsigned distance, and now you have updated the classifier to move it up, and this is W2 equals W1 plus again y double prime phi x double prime. Okay, and after this the unsigned distance we expect, and this is what happens, y double prime W transpose W2 transpose phi x double prime would be positive as expected. Okay, so our observation is perceptron does not find the best separating hyperplane. So we will have a disclaimer and we will explain this later. It finds any separating hyperplane, and we will show that in the next class. We will show that it actually always gives you, it converges if the points are linearly separable. If there actually exists a linear separator, it will find that. So what we mean by this is that if this is the space right, and these are the positive points, these are the negative points. The perceptron update rule may find you this classifier, whereas a better classifier such as SVM might find you this classifier. See, the grey classifier gives you some breathing space. It will help you generalize better, whereas the black one will just manage to classify, like just pass exams, right? You just study before exam, just pass them. So the margin is, oh, I could have passed comfortably. Okay, so this is the story of SVMs. They give enough breathing space, whereas perceptron, a poor man's classifier, which has today become very rich. That's perceptron. Okay, we'll talk about it. Support vector machine. I'm just giving you an idea that there are other classifiers. Okay, so this is a perceptron update rule. We already discussed. A point is misclassified if the sign distance is negative, and keep repeating. If unsigned distance is negative, then wk plus 1 equals wk plus y times, you can put an eta if required, phi x. Okay, I am going to quickly in one slide explain why this tends to work. The intuition is here. Okay, let's just write down this dot product. All of you write down this dot product after the update. I have the update in front of you. Wk plus 1 is wk. Write down this unsigned distance, supposed unsigned distance after the update, which means substitute for wk plus 1. Very simple, one step. What is it a sum of? The unsigned distance after update, it is a sum of the unsigned distance before update plus this y square, all of you see it's always 1, right? Y square is always plus 1, and phi transpose phi x is norm phi, which is always positive, plus a positive quantity. So what do you see? After update, has the unsigned distance increased? It has become more positive, right? The unsigned distance after update tends to be more positive. I just want to give you this hint. We will continue this next time, even if you didn't understand it fully. I just want to help you appreciate that very simple idea here, which makes the unsigned distance after update more positive.